Hi guys, we're going to have a look at sums and products of functions. This is pretty easy, so no stress required. There's just one little trick to this which you really need to get right, which I'll explain in a moment. Okay, the sums of functions. F plus g bracket of x is just basically f of x plus g of x. So this is the trick. The function f plus g of x is only valid where both f of x and g of x are both valid together. That is the intersection of their domains, which means the domain that they both have in common, that works for both of them at the same time. That is the trick. The product of functions works exactly the same way. F times g of x is just f of x times g of x. Again, it only works for the domains which is working simultaneously for both of them. Okay, if you get outside of that domain, then you're in trouble. The functions are not defined. As an example, f of x equals x and g of x equals 2x. The domain, the implied domain of this, of course, would just be R, and of this one also would be R. And therefore, f plus g of x is just f of x plus g of x, which is x plus 2x, which gets you 3x, where x is any real number. That's pretty simple, isn't it? This really is just a case of addition of ordinates, that is the y values for a given value of x, which is in the domain of both functions. The x's have to belong to both functions, yeah? We could do a table of values just to really flesh this out a little bit. Not really necessary, but I just thought I'd do it for you just to show you, okay? There's a table of values of x. That would be f of x, which is just x, and this would be g of x, which is 2x. Now, f plus g of x is simply the addition of those two red numbers, okay? You get it, don't you? Not rocket science this, it's pretty easy, yeah? So, we know that f plus g of x is f of x plus g of x, which is x plus 2x, which is 3x, and Bob's your uncle. Now, graphically, we could do this graphically by adding our ordinates. I will show you. There's f of x equals x, and there's g of x equals 2x. Now, if you want to work out what f plus g of x is, you add the ordinates being the y values for any given chosen value of x together, and you'll get f plus g of x. You see, I'll show you. There's a particular value of x that I've picked, and you can see that height of that little line there is the y value for f of x, yeah? And the height of that little line there shown in green is representing the y value of g of x, okay? Now if you added those two y values together for that particular value of x which I've chosen, you'll get that yellow line, which is f plus g of x. It's the y value combined, adding them up individually to get a combined y value, and there it is. See, that's addition of ordinates. That's what that refers to, adding the y values. There's another value of x on the other side of the y-axis, same procedure. There are the two y values, add them together and you'll get f plus g of x for that particular value of x. Now doing that for repeated values of x, you could get yourself a very nice little track which you could join the dots for to get the result being f plus g of x. But of course it's going to be a straight line, so we really only need 2 points, and we've got 2 points there. We're going to draw a line through them, and there she be. Okay, that's f plus g of x, which is f of x plus g of x, which is 3x, and Bob's your uncle. It's very simple, isn't it? Yeah, very simple for that one, because that one's got a sort of an unlimited domain. Let's go through f times g of x now. And then we might have a look at some restricted domain stuff, the fussy functions. Take a table of values. Yeah, same old, same thing. There's f of x and g of x. Now we multiply those two red values together to get the value of f times g of x. Yeah, does it? Have a look. Have a look. Does it make sense? I think it does. So that's how it goes. That's how it goes, guys. F times g of x is just f of x times g of x, which is x times 2x, which gets you 2x squared, which is going to be a quadratic. Okay? Graphically again, let's do that. Okay, now there's f of x, there's g of x. Now this time we've got to multiply the y values together for a particular value of x of the red graph and the blue graph to get the f times g of x values. Okay, there's a value of x, I've chosen 2, okay, and there's f of x, and there's g of x, which is 4 for when x is 2, so 2 4s are 8, and there she is. You see, that's the value for when x is 2 of f times g of x. And if you did that for a few different points, you would get a very nice little quadratic curve, I promise you. There it is, look. How lovely. And it's going to be 2x squared, as we found out over here. See, it's not rocket science and you can do it. Now here's the big NB. The big NB, which by the way stands for nota bene, which is Latin for note well. Okay, students ask me that. Okay, the sums and the products are only valid for values of x which apply to both. That's what I've been saying. That is the trick, that is the thing you need to get into your head, because that's the thing they'll ask you. Okay, so the domain of f plus g is the intersection of the domains of f and g, and similarly for the domain of f times g is the intersection of the domains of f and g. Yeah? Alright, now here are a couple of fussies, so we're going to really put this to the test now to see whether you truly understand it. Okay? F of x is this little beastie and g of x is that. Now they are both fussies and they have their own particular domains which work for them, and we're only allowed to use the domain which is common to both if we're going to add them up or multiply them together. So for f of x we know that what's under the square root sign cannot be negative, so therefore it's greater than or equal to 0, and therefore x is greater than or equal to 4. Now similarly for g of x we know that 10 minus x must be greater than or equal to 0, which if you work all that out correctly you will get x is less than or equal to 10. So this is pretty interesting. Okay, let's draw a number line to see what's going on. That's the situation for f of x, that's the domain of f. You'll notice that it includes this knobbly dot here where x is 4. Here is the domain for g, okay? Again, knobbly dot on 10 and going backwards towards minus infinity. Have you got it? So what do you think the domain for f plus g of x or f times g of x is going to be? Yes, it's the overlapping bit, the bit that they both have in common. So it's going to be, basically, from 4 to 10 inclusive. Voila! You get that, don't you? Terrific! Now, this example is just asking us the following questions, which we can now do quite easily. Yeah? So let's do A. F times g would simply be the product of those two functions. Yes? Makes sense, doesn't it? And we know that the domain is going to be, yes, see, one of them's got greater than or equal to 4. This one's less than or equal to 6, and therefore the domain that's in common to both of them is going to be from 4 to 6 inclusive. So there's our answer. There's the function. There's the domain. Now I've worked out the domain because I thought it was the right thing to do. If they don't ask you, I suggest you do it anyway, okay? Because the domain really is important, okay, for these functions. Now, what have we got here? F times g of 5. Well, that's all right because 5 is within our domain and we can easily work it out. We can just plug 5 into here, can't we? And it's going to be that. Have a look, have a look. Yeah, it's right, isn't it? So therefore, that's going to be 1. Terrific, terrific. This is pretty easy, isn't it? F plus g, alright, well that's pretty easy, there it is, and we know that the domain is from here to here. We found that out before, didn't we? Yeah, good. And what about D? F plus g of 5, no problem, we just plug 5 into all this, and we're going to get that, which is going to be 2. There it is. Woohoo, we got 2 for me and you, and that's great.